This video is going to cover the two-sample test for population proportion. So this would be the case when you have two samples and you're looking at something categorical. So in my case, I looked at my class, and I looked at Mr. Hammond's class, and I looked at the proportion of seniors that we have. And I want to know if the proportion of seniors is different in my class versus Mr. Hammond's class. Now, in order to carry this out, we need to make sure our assumptions are met. So the first assumption that has to be checked for every test or interval is that you have a random sample. This is going to be the case unless you skewed your study some way or you had a poor study design. Now, if we look at the assumptions for the two-sample test for proportion, they're the same as the one-sample test for proportion, except that the assumption has to be checked for both samples. So both samples have to be large. So you have to check that NP is greater than 10 and N1 minus P is at least 10. So if I go to my Fathom dataset, I'm looking at the Budden-Hammond dataset. So that's here. So I looked at the class standings in my class and the class standings in Mr. Hammond's class. If you look at the summary for each class, this will give us our N and our P. So N is 29. The P is the sample proportion of seniors. So in my class, that's 9 out of 29. So it must be true that N, 29, times 9 out of 29 is at least 10. That is not met. That fails. It also has to be true that 29 times 1 minus 9 out of 29 is at least 10. That is met. I need to check the same thing in Mr. Hammond's class. So 11 out of 29 times 29 is greater than 10. 29 times 1 minus 11 out of 29 is greater than 10. So Mr. Hammond's class is met, my class is not. In this case, we're going to keep moving forward anyway just to show you how to use Fathom. But if it ends up being the case that your data set does not meet the assumptions, you need to either talk to me, Ms. Budden, or talk to your mentor about how to proceed. So now that I've checked my assumptions, I want to carry out the test. I am carrying out a test in the upper right for comparing proportions. I am looking at my class versus Mr. Hammond's class. Anything in blue is something I can change. So I need to tell Fathom exactly what to look at. Fathom right now is looking at the freshmen. I don't want to look at the freshmen, so I'm going to change both of those to seniors. Right now, Fathom is checking that the proportion of seniors in my class is not the same as Mr. Hammond's class. So that's what I wanted. I can change that, though, if I wanted it to check greater than or less than. I end up with a p-value at the bottom of 0.58. Because that is bigger than 0.05, we fail to reject the null. Fail to reject the null means that there's not enough evidence that the proportion of seniors in my class is different from Mr. Hammond's class. While yes, they could be different, we cannot prove for sure that they are. Normally, a hypothesis test is followed up by a confidence interval, which is under estimate. You're going to change this to difference of proportions. Again, you're going to have to change the same statistics. So we're looking at Budden versus Hammond. We are looking at seniors. Normally, a 95% confidence interval is carried out. I would suggest you leave that at 95%, unless your mentor tells you to change it. This is our confidence interval. So the difference in the proportion of seniors between my class and Mr. Hammond's class is somewhere between negative 0.31 and 0.175. Because 0 is in the interval, that indicates to us that it's possible that the two classes have the same proportion of seniors. Doesn't mean for sure that they do, just means that it's possible, which confirms the test that we did earlier.